So there is some overlap, but I'm going to give a short introduction, then I'm going to talk about new shapes for shells as well, the modeling techniques, and the application of physical models in Heinz Isler's design process, because he didn't just use models for form finding, he used them for exploratory models and structural verification. And then a few concluding remarks, just thoughts from myself. Throughout his career, Heinz Isler was a fervent advocate of the use of physical models. He really thought physical models were extremely important. And the reason for that is, he said, engineers actually build physical three-dimensional objects. We don't build two-dimensional flat drawings, we build three-dimensional objects. And those are subject to the laws of physics. So the best way to prove those is to build a physical model. And again, we've seen this photograph. I think it may have been my photograph originally. He believed that the physical model can be used to reveal the statical behavior of whatever you're designing. And it also shows how the physical properties of the materials influence the structure. And very nicely, it gives you some indication of the stiffness of the structure. You can't just push the computer screen and find out how rigid your structure is, but with a model, you can touch it. And if you push it and it moves, you think that's not very rigid. So he really liked that aspect of his models. And then you can compare the proportions with a physical model from the architectural point of view. And if you push it and it breaks or it cracks, makes a cracking noise, you know there's something wrong. You can't do that with a computer model either. As I think it was Juan showed this morning, this example he had in his office of, press the wrong button, the plastic sheet and the flat plastic sheet, which is acting as a beam over two supports. Very small load on that and you get the massive deflection. The deformed plastic sheet into a double curve structure, and you can put 30 times the load onto it, and it barely deforms. And as one or two speakers have already mentioned, perhaps the most influential of Heinz Isler's papers was the original one, New Shapes for Shells, in not the first, but the most influential, New Shapes for Shells in 1959 at the first Congress of the International Association for Shell Structures, as it was, organized by Eduardo Torroja in Madrid. And the paper was published in the ISS Bulletin, as it used to be called, not the journal, issue number 8. And typically of Heinz Isler, when he was writing about his own work, the text was very brief. In total, it was a 5-page paper, and you got 1 page of images, 1 page of text, another page of images, another page with a very small text, and then the last page you get this well-known diagram, which I call 39 etc. There are 39 different sketches that Heinz made himself, and then at the end here you have etc. to show that actually there are an infinite number, an infinite spectrum of different shapes that you can get using the freely shaped hill, or the membrane under pressure, or the hanging cloth reversed, as he called it. in contrast to the 5-page paper with 1 page of text, the discussion reported for the paper was 5 pages of dense text, because he was attacked, you can say. If you read some of the questions, he was actually attacked by Toroja, Ovearup, Nicolas Esquillon, who just finished the CNIT in Paris. They were saying things like, how can you construct shells economically and efficiently with these free shapes? Because it's really expensive to build geometric shapes, so how can you do these free shapes? And I forget who it was exactly, but someone commented, could you take a statue and curved statue and make that into a shell? And he defended himself really well. And at the end, he just said, the shells, the most important thing is the shape, and thank you very much. That was his last remark in the discussion. And I think if you can read that carefully, although if you can't read that, I did write a paper back in 2009, the year when Heinz Isler died. I wrote a paper for the ISS conference in Valencia, which sort of reviewed his New Shapes for Shells paper. And it is open access, so you can look at it, download it if you like. So his different methods, which we've seen in some of the other presentations, the freely shaped hill, and I don't suppose you use that very often, but this very nice hill for making a reinforced polyester structure, 6 meters span. So he wasn't just reinforced concrete shells, as has been mentioned earlier. He did actually do a lot of development work on fiber reinforced plastics over the years. And the membrane under pressure, as we've seen before, this is one of his 1 or 2 rigs that he had in his office, and these images are being taken from a book chapter that I've written but hasn't yet been published. And in the chapter I note in one of Heinz Isler's papers, he says that using this method, he was trying to measure the surface of the inflated membrane. And he found that the membrane surface, instead of going down, deflating, it was inflating. So the curvature was actually getting greater, the heights were getting higher. And in the end, he realized this was due to his own body heat, heating the gas inside the membrane, and therefore it was sort of inflating it slightly more. So he wore heavy clothing and gloves to do the measurements, to insulate himself. And the third method described in the paper, the hanging cloth reversed. This is just a couple of photographs of one of the many hanging models that he had all around the office. I think this one is actually in his garage in his house. So he didn't just do them in the office, he took his work home with him. And these are cloth models, because in the paper he says the hanging cloth reversed. The problem with hanging a cloth is that you have a warp and weft, and if you hang it with the warp and weft at right angles to each other, you get one form. If you hang it with the warp and weft at 45 degrees, you get a different form. So it's one way of finding a shape, but it's not particularly accurate. And a fourth method that he didn't include in that paper was the expansion forms that he also used later on. And in discussions with him, he never really said what led him to do this, except seeing bread rising way that formed under pressure of the yeast, that formed a nice curved surface that he thought he would investigate. And in discussions with him and in all his papers, the thing that he emphasized most greatly was that you need absolute precision when you're measuring the forms. When he was using the hanging cloth reverse method, he eventually ended up with a cast, plaster cast, and this is the jig he measured in, and you can see here on the surface of the cast, that's the grid that he measured all these points, and he said he was measuring those points up to 10 or 12 times at each position. And using a system, this is sort of a balanced weight system, and he can measure to 0.01 0.01 millimeters. So he's measuring to 100th of a millimeter because he's scaling up from that up to 50 times. But even then, he's measuring effectively to 2 millimeters on the final structure. And the density of the grid is less in the center here and gets greater towards the corners. Application of exploratory models. He's a bit of an architect as well, not just engineer. This is the exploratory model for the Lomisville Church, which is one of the few high-power surfaces that Heinz-Isler did. And you can see here it's just made out of sticks and some knitting wool to give some impression of the high-power surface. And then on the right here is the way he found the actual surface of the high power in the church, taking the original, just sort of normal high power surface, lifting one side, lifting one end, and then carving a piece out of that surface. So we're using models in the design process in a different way. Exploratory models to work out how the shell works, how you might potentially avoid buckling. You could put a ring beam round here, or you can have some nice tension cables as applied in the Bellinzona shell to prevent buckling of the corner supports. Again, we've seen this plated membrane jig, and as was mentioned before, the corners are turned down, and one of the things, if you just inflate a flat membrane, you do get a sort of a reverse curvature in the corner, and this is one way of avoiding it. Another way of avoiding it is the earlier inflation jig that I showed had rounded corners, and that also avoids getting the reverse curvature in the corners. But for the more exotic of his shells, he used the hanging cloth reverse method, but didn't use a cloth. This was the essential point that because of the orientation of the warp and weft in the woven material gives you a different form. You have to have an isotropic material, so he used thin latex rubber. And I think this is one of the few models that were left in the office when after he died, which still had the plaster on and the latex rubber. And you can see that the supports are fixed, and he started drawing the measuring grid on here, but the latex rubber stretches equally in all directions. You might assume that you start with a flat sheet of rubber, because that doesn't quite work. So you have to have some sort of oversized piece of sheet of rubber. So it needs more than one experiment to come to a final form. In the office, there were many. Just for this sickly shell, that was the most complex one that he did on 7 supports. So yeah, when you went to the office, you saw stacks of these plaster casts from the hanging models. But I think the other models that he used were larger scale. This is the model that he made of the Bellinzona shell, which is about 30 meters by 30 meters. And this is in the grounds of the office to 1/10 scale. And the thickness of the shell is just 8 millimeters. And that was built at approximately the same time as the main shell, the full-size shell. And this doesn't have any pre-stressing in the corners, yet it's subject to exactly the same load as the full-size shell. So he kept this as a sort of reminder that as long as this would stand, then the full-size shells should also stand. For me, I think we're talking about the impact of his modelling on the design development. Actually, I think although people look at his form-finding methods and think of the innovative form-finding methods, I think the most important models he made were the structural verification models. Because any form that he was coming up with his methods could potentially be a shell structure because of the methods he was using. But what is the most efficient and what are the stresses within that surface? So he used the structural verification models to refine the final designs. This is one for one of his what I call the ubiquitous bubble shells, because there are hundreds of them all over Switzerland, and some in Germany and so on. And you can see how sophisticated the model is, made out of plexiglass. And these are techniques he learnt from his professor Pierre Lardy, who inherited those or with the contact with Eduardo Torroja. But very complex models where you can model the pre-stressing in the edges and so on. And the system of loading the structure with these beam system underneath here means that you can have a uniform load, or you can have half load and so on, and some non-symmetrical loading and so on can be applied. And I think you could see from these verification models the structures that he was most concerned about. This, I think, is the verification model for the Reckersville shell, which was one of the expansion forms. And you can see this sector here, you've got a lot of strain gauges in that section, and along the edges here, all of the edges. And I think he was perhaps more concerned about the performance of that sort of shell because of the form-finding method. And then the really complex ones, like the sickly shell, you've got this massive model. You're investing a huge amount of time in making a model like that. So you're only going to make one of them. You're not going to make 10. So this is I think, the critical phase in his design development. At this stage, he's really getting to understand how the shell works. And in these models, you can move the supports to simulate pre-stressing or deformation of the supports. Equally in this model for the Lomisfield Church, which we were looking at the exploratory model earlier on. You can see there, although it's a hyperbolic paraboloid surface, he's applying some pre-stressing in the surface there to counteract tensile stresses. And he's not just modelling the shell, he's modelling the supporting walls as well, all in plexiglass. Including this cutout window in one of the walls. So I said I'd probably be reasonably brief. Heinz Isler really, throughout his career, defended the effectiveness of his physical modelling techniques, and those were used at all stages of his design. But he was very aware that they were only an approximation. The most important model is the one-to-one model, the one that you make at full scale. And for many of his shells, he monitored the deflections of the shells. He realized that if you are going to monitor a structure, perhaps the cheapest way to do that, you can't have strain gauges all over your massive shell. The easiest way to do that is to measure the deflections and compare those with expected deflections. And if you get large deflections, your shell shape is not very good. So he considered those to be further experiments. And through feedback from his constructed projects, such as the tennis ball shells, he gradually changed that in the paper that he published or he presented at ISS 20 years after the new shapes for shells, he said he gradually modified the form of this structure, first by 3 centimetres, then by 6 centimetres, presumably at the middle, and smoothed it out to get an optimum solution. And to me, this indicates that the form-finding process, although important, the modelling process to find the shapes was important, but the experience that he gained over the years was equally important, or perhaps more important, that he, through the use of models, being able to touch the models, to have the physical contact and realise how stiff they were, he could then, from that experience, know how he needed to change the form to improve the performance without going back and doing another structure verification model. So over the 50 years, Heinz Isler was responsible for the engineering of many shells, 1,400 approximately, and in some cases the architectural design. They were mainly realized through the models, and the evolution was mainly, I think, through the feedback from his full-scale structures. The important thing is that he realized that you had to have this great precision when you're modeling, at all stages of the modeling. And perhaps there is a place for making models again today to supplement other digital technologies. I've recently been working with Andrew Borgart from TU Delft, and they have a few scans of Isler shells from the office taken before they were moved to Zurich, and they have, with the process, they've found the shape of the shell, and they've been able to use that to three-dimensionally machine a surface and then vacuum mold shells from that. So equally, that process can be used for 3D printing of shells and so on. But one thing that I think applies to Heinz's methods, no matter how precise his methods were making the shells forms, finding the shell forms, and measuring the shell forms, if you're using those sort of methods, you're never going to get absolute symmetry. So you have a nice shell on 4 supports. It should, in theory, be symmetrical about 2 axes. And if you're going to measure it, and if you're using that process where you're putting plaster on a flexible surface, you're never going to get absolute symmetry when you measure it. So which surface do you choose? Do you average the 4 corners, the 4 quadrants, or you take one quadrant and think that might be the best one, or this one, or that one? So within the methods that he had, there was a lot of engineering judgment as well as aesthetic judgment of the shell surfaces. That's my sort of concluding thoughts, but Juan missed this opportunity this morning. Juan is one of the membership secretaries or membership committee members for ISS, and I think everyone in this room who is interested in shells should be a member of the International Association for Shell and Spatial Structures. So as an executive council, fellow executive council member, I would encourage you all to join ISS. Unfortunately, the cover that I put on, I realise, has got Otto on, not a shell builder. But if you look at ISS-structures.org, the membership page, the membership fee for students is so low that it's €10. And you can get access to the journal and conferences. For individual members, fee is €85, but you get a discount of €100 on the conference every year or the symposium every year, so actually make a profit if you're a member. And you still get the journal. So sorry about the advert at the end, but thank you very much.
Good evening, since it's already 7 p.m. And first of all, I would like to thank Dino and all the Mexican group for organizing this first meeting. It was really a pleasure to be here and to visit all these Candela buildings. It was the first time for me in Mexico, so I had a very nice impression. So what I'm going to present is basically an overview of what I would like to do during my PhD, because I am one of the 2 PhD students on the Isler research project at ETH. And I started not even 1 year ago, in January. So I would like to share with you the first thoughts, the first reflections that I had in these months, and then I would like to share with you the next steps that I would like to do. So first of all, what for me is really interesting and surprising is how prolific Isler was in his career. Maybe he was the most prolific shell builder in the world. And he was basing, as John already explained very well, he was basing his methodology, his design technique on physical models, so on exploration, experimental explorations. And the topic of the PhD that I'm going to develop is the primary role of the physical models in Heinz Isler's development of design and construction techniques. So First of all, I would like to speak briefly about the context, so the international context where Isler is placed, and also a bit about the Swiss context. And then I would like to explain you a bit how I would like to develop the research in the next months and next years. So, as we all know, since we are here to visit the Candela buildings, Isler was just one of the people that in the post-war period were developing shell structures. Sorry, Claudio, that Amancio Williams is not in this, but next time in Berlin it will be there. Yeah, they are not, some of them are very well known, others are maybe less known, for example, this Romanian Bertrand Goldo and the American one. And they were all very fascinated about shell structures and especially about the property of the shape of the shell, because as Heinz Isler was pointing out, is that the shell is such a dominant structure that it needs no addition of other dominant elements, and the shell is the supporting structure and the space enclosure at the same time. So the shell is basically the shape that is combining together engineering and architecture. And this is something that they were exploring in very different ways all around the world with very different form-finding methodologies and techniques. But all of them, they were trying to face the three-dimensional problem of defining the shape and the shell. So first of all, a statical problem, so related to the boundary condition, the supports and the buckling stability in the shell itself. But then they were struggling with the shape and also with some more architectural understanding of it. So, for example, function of the shell, and then acoustical problems and lighting problems, so illuminance problems. Most of them, they were focusing then on the form-finding methodologies to it. So some of them were going more into analytical methodologies. Heinz Isler, for example, was developing experimental approaches using physical models. But he was also pretty rooted in the Swiss context, and I would like to share with you some reflections about it. Bringing some two people, one that was already presented before, and another one that was an architect that was contemporary of Heinz Isler. Pierre Lardy was his professor at TTH and was also professor of Christian Mann. And maybe the main important lesson that he gave to Isler and Mann was the elegance of the structures, so the elegance of developing a good design through the lightness of it and the integration between the different disciplines. And he was also the one that met Eduardo Torroja. He saw the model lab in Madrid, and he decided to open and found his own model lab at ETH. And actually, this was the moment when Heinz Isler started looking at physical models. Then the second person, he was an architect, and he was developing his architectures just 1 hour far from Heinz Isler, because he was working mainly in Basel. I actually don't know if they were in touch or there were connections. This is something that I should explore a bit more. But to me, it's pretty fascinating because he was also developing shell structures in reinforced concrete in the same period and using also physical models to develop it. And this is something that is, to me, pretty interesting. But apart from the architecture itself, for me was pretty important reading this book that is a book about the models and the importance of the physical models in the statical behavior of structures that he published in 1971. I would say that maybe Hausdorff was maybe pretty more theoretical than Isler, and he was really defining the model as a tool for design. that was speculative. So from a theoretical point of view, he was considering the model as a representation of nature, as mimesis, but at the same time was explorative because it was really a tool for designing things. And to summarize all his thoughts, then he was speaking about building as Baukunst, that is a German word that is a bit difficult to explain in English, but he was basically trying to explain it through the combination between the scientific approach, that is engineering approach, and the aesthetic approach, that was the architectural approach. And in this book, he published also this diagram where he was stating and defining the importance of the physical model compared to the classical methodologies and the computer analysis, saying that just through the physical model is possible really to push the limits of structures, of structural behavior, and to explore something that in nature is present but is very difficult to define through analytical methodologies or digital methodologies. So basically, Isler, that started working in the 50s, he was really in the middle of all this environment, cultural environment, scientific environment. So from Torroja, Pierre Lardy, then in the same years it was published a new code in Switzerland that was allowing the use of physical models for calculation, for verification of structures. And then maybe at the very end there was Heinz Osdorf that published this book that I explained to you. So in the second part of my presentation, I would like to explain you a bit the process, which is both the process of the research plan that I'm developing and also the process of Heinz Isler design development and construction development. Yeah, obviously the starting point is always the first ISS conference in Madrid, and for me it's really fascinating the fact that when Heinz Isler came to the international stage was just in his 30s, so 33, and just a few years later than me. And he had this great intuition, and basically he then developed his own career, his entire career, basing it on the intuition that he had when he was 30 years old. Developing these endless possibilities of shells through very different models. So very different model making techniques, very different materials, and very different understandings of them. So in the first part, I would like to define a bit of my research. I would like to define a bit the model making techniques, because as John was also saying, the most important thing is the touch between us and the things. And this is something that also Pierluigi Nervi wrote in 1945 in his first publication. And it's something that also Isler was really taking into account. And the fact that experimental research opens up endless construction possibilities. So he was using these model-making techniques, and in this part of the research I would like to define a bit and understand the different techniques that he was developing for the different buildings, and if there was a development inside the single techniques. So for example, in the case of the geometrical shape, that he was using more this geometrical shape for sculptures, so mainly for the Duarte collaboration of the sculptures. Some hyperbolic structure, and in some cases used also for architecture, for example the church in Lomisville and Villa Camoletti, but then also the pneumatic form that he was using for industrial buildings and the bubble houses, the flow form that he was using to define mainly the garden centers, and then the hanging membrane that were really opening up endless possibilities, the free-form buildings. And in March, we had the opportunity to interview Hans Glanzmann, that was the previous collaborator of Heinz Isler in his office, and it was really interesting for me especially to understand from his point of view, that was really the person that was taking care of the models in the model lab of Heinz Isler, how he was developing it and which were the problems that he was encountering. And also having the discussion with Heinz Bösiger, that was instead his contractor, the contractor of most of the buildings that he developed in Switzerland and abroad. But then the model, as said, was really important, was not just a tool, as Heinz Hausdorff was saying, but instead in the case of Isler was really part of the design process and the development also of the construction techniques. So in the second and third part of the research, I would like to start understanding the projects and the project development of Heinz Isler through the lens of the physical models. So because he was using really the physical models in all the design development phases of his projects, so from the mass model till the measuring models and the presentation models. And I would like to start making connection with all the projects or some selected projects of it. Starting to understand really the production of the Isler pneumatic shells throughout the years, how they are related to the physical models, and if there was also a connection with the physical models in the development of this design. And maybe the Blaser Swiss Loop project that Matthias explained could be also considered a paradigm in this sense. So just to make you an example, I would like to pick some projects that are very close to each other and refer them to the models that he was using, trying and starting to really define how he was going from this model to this one and through this one, referring always to the built object, and then looking also at the detailed solution that he was applying that are visible already in the physical models, obviously. And starting from that, then he was really starting playing with different dimensions, combining them in different groups. And this is something that I started doing with the industrial shell buildings of Heinz Isler, that are the green ones above. But I would like to do it also with the freeform shells, and this is maybe much more challenging to do. But Isler was really interested also in the construction development, so really in how the things and the ideas that he had in mind, he was applying them into the construction process. So I would like to read all the projects, considering them as real scale models. So considering also the built object as a real scale model, using some evaluation criteria, considering the deformation pattern, the method of construction and the cost of it, in order to define if there was then a connection with the future projects in a more consistent way. So to summarize, this is something that he was doing, we know that he was doing, for example, for the pavilion Sicily, because it was one of maybe the most complex free-form shell that he developed, but it's something that he also used for other projects maybe less known. So it means that the design and the constructions were not just linked with a linear connection, but in the case of Isler, the model was really in the middle, and there was like a cycle between the design and the construction phases. So to conclude, I would like to go back to what Heinz Hausdorff was saying, so when he was considering the model as a tool. And from what I understood in these first months of my research, instead in Isler, he was really considering the model as part of design and the construction process. So it was not a way, like a tool, as Heinz Hausdorff was saying, to combine engineering and architecture, But since for Isler the shell itself was, the form itself was combining engineering and architecture, he was using the model to combine the design phase with the construction phase. So in this case, building for him was really related to the process of construction. And one of the main questions that I have in this period is then how we can relate this one with the Baukunst and how can we relate this one to the structural art that David Billington was saying. And this is something that I would like to investigate in the next months and years. Thank you very much.
Well, I have learned a lot of my colleagues. I think that all this work from Hans Eisler is very, very important, and his methods of design and construction. I will show you part of my architectural practice during the 60s, which was related to the church building, church construction and design. And we will take the church you have already visited, the Chotepingo neighborhood, Mexico City, between 62 and 87. That means that it took a very long time to finish that work. Please, the next. Before explaining this design, I will explain also that I work with Enrique de la Mora y Palomar, who has started since he was a pioneer since 1938 in contemporary Mexican religious architecture, but he had started since 54, a new stage in his practice, introducing the use of concrete shells of warped geometry, with Felix Candela as consultant and builder of such kind of geometrical solutions. Our approach, de la Mora's approach, and all his disciples were geometry as the starting point to design the church, the shell. Between 57 and 58, I started to work with de la Mora, in whose office Fernando López Carmona was then main design manager. He was also in charge of introducing newcomers like me in the secrets of the geometry of warped surfaces, mostly parabolic hyperboloids, hypars, conoids, and other geometrical solutions. In de la Mora's office, I witnessed the design and building processes of several examples that soon became very famous. The Mexican Stock Exchange Hall, 54 and 57, and the churches of El Altillo, 55 to 59, San José Obrero, 56, unfinished, San Antonio de las Huertas, also unfinished, and others. There too, I started to propose solutions myself, employing such, in this office, employing such type of concrete shells. We show some examples. These were two not built projects where I have to learning with López Carmona and de la Mora how to develop this kind of solutions, no? And especially in churches. The next. This was a very complicated example with I traced myself, I made this drawing, which shows a section of a very complicated church using hypars. Next. Between 58 and 59, a scholarship allowed me to stay 1 year in Germany, and I had the opportunity to visit good architecture in most European countries. Of course, I was impressed by the medieval church architecture there that later would influence my design of the Xochotepingo church. But in 60 and 61, I worked again with de la Mora, associated to important projects, and in 62, then 28 years old, opened my own office architectural firm associated with Leonardo Vilchis, a colleague friend of mine. In our office of 30 square meters, we designed a church for the neighborhood of El Rosedal, then attended by a member of the San Felipe Neri order, Father Miguel Herrera. There it shows the basilical display. It's just a rectangle, then still in use, with the altar at the end of a long nave. Our design for the main roof consisted of 3 pairs of umbrellas, each composed by 4 hypars, and we called Felix Candela as consultant and builder through his own company, Cubierta Sala. Father Herrera accepted our solution, and the building process started in the spring of '62. Next. This is the solution, the geometrical solution of the 6 umbrellas, each consisting of 4 hypers, and the result of the interior, which was what we are looking for. Next. But soon the first pair of umbrellas at El Rosedal started its race, and Father Herrera was delighted and asked Felix Candela, who visited daily the building progress, if he could design another one nearby, the San Antonio de Padua Church in Xotepingo. Neither Father Herrera nor Felix Candela mentioned me that episode, but several weeks later, Candela made me a phone call explaining the issue, adding that he had already a solution, that Father Herrera had accepted it, and that, of course, both he and myself would share the credit if the project would be built. I answered him that I didn't accept to share the credit of his design and wished him good luck. Then I called Father Herrera, who tried to explain me the embarrassing situation as a mistake of him because he believed that Candela and myself were partners. I also wished him good luck with the Xotepingo Church. Naturally, I was disappointed with both Candela and Father Herrera. But perhaps a month later, probably in September '62, Father Herrera called me again, telling me that the Candela design had been rejected by the religious authority of the Metropolitan Archdiocese because his solution was only an interesting cover without care for the liturgical activities inside. At the same time, Father Herrera asked me to help him to solve the problem and to start a new solution, and as he felt himself in compromise with Candela, he added that he begged me to call him again as consultant and builder. Next one. So I started with Leonardo Vilchis, my partner, our design for the church in Xotepingo. The site was a long and narrow triangular plot between a main avenue and a secondary street, you have already seen. And our solution consisted of six high parts arising from the ground, covering most of the surface available. Inside, we proposed a timid departure of the basilical layout, locating the presbytery at the center of the 3 axes coming from 3 axes. Then we showed our solution to Candela. Meanwhile, Father Herrera showed the same material to the office of the Archdiocese that allowed him to continue. Candela asked us if we had seen a similar solution somewhere, and we answered that it was a result of our own design work. Then he added that he had been recently in Tokyo, where a colleague, did not mention his name, showed him some sketches very similar to ours. He was obviously puzzled, but kept our project and promised to study its structural feasibility. Next one. I am sure that Candela worked hardly in our preliminary sketches for the church at Xotepingo, and only in 1966, we realized that the similar solution he had seen in Japan was a master work from Kenzo Tange, the Cathedral of St. Mary's in Tokyo. Here is, in the left is the Cathedral of Tokyo, and on the right side is our own sketches, preliminary sketches. Next one. We waited several weeks with occasional phone calls to Candela to have information of his progress, But suddenly he suffered the loss of his first wife, and we prudently waited for another 2 months. Then in April '63, Candela sent us a letter, I have that letter, announcing that despite his efforts, he had found that our design was structurally unfeasible, and at the same time that he would no longer participate as consultant and builder, and that we could ask Juan Antonio Tonda, his best disciple, to accept the same role. By then, the community of Xotepingo, with the provisional church that you see there, that had waited patiently during almost 1 year, was already restless because they felt that meanwhile they had economically contributed to the building of this church without results. In this situation, Padre Herrera asked me to develop as quickly as possible another solution that allowed us to start soon the building process of the promised church. In just 1 week, the design started with a partial solution, a sort of slice, in Spanish, un gajo, of the nave. The next. The slice was a rigid frame, a structural mixture because it combined vertical supports of other concrete slabs 10 centimeters thick, with a roof consisting of 4 high parts of concrete shells 4 centimeters thick. We discussed it with Juan Tonda, who devised the structural feasibility of such fragment that multiplied allowed us to cover the whole nave. That solution had many advantages because each slice was structurally independent. It allowed but didn't need the contiguity of other fragments for its stability. In 1963, the building process started with the foundation of the nave, and soon the first slice emerged, giving the community of Xotepingo a silhouette of the nave. So they started to give a better contribution, thus arising a better contribution response. Along several years, all the slices were built using only one set of wood molding for the entire set of slices. Despite the slow swelling process, the church soon changed its rank of chapel and became a parish church, and Father Herrera ascended from chaplain to a parish priest. Next one. These are the structural solutions of Juan Tonda for the church. And the rate, you see the elevation of the slice. And next is the plan of how it grows from very short support to the top of the nave. Next. And one of the advantages of the add-on slices method we used was that allowed us to introduce easily some changes. For instance, we added around the altar an ambulatory and 2 little chapels, as well as emergency exits and accesses to the crypt. The next one. And this was the result, no, that you have already seen. Next one. The interior and exterior repetitive and pointed morphology of the Xotepingo Church is a sort of homage I made to the European medieval church architecture. I think I learned something about Gothic cathedrals and Romanesque cathedral, but I translated it into contemporary terms in the Xotepingo Church. Next. For the crypt under the main altar, we solved its vault with convergent and folded concrete slabs 15 centimeters thick because they had they support all the presbytery and the altar upside. Next. Something I learned with the La Mora and tried to apply it in the churches that I could build was to look for the proper assistance of other arts and handcrafts to underline the religious messages of such type of buildings. For such task, I called an experienced painter, José Reyes Mesa. This was my design of the frontispiece. The artist's proposals was that, and its realization was in stoneware, and also the glass stained window there. Next one. And Reyes Mesa designed two stained glass windows on the sides with glasses of the prestigious factory in Chartres, imported glasses. Next one. The combination of workers' surfaces, stained glass windows, tapestries, liturgical accessories, upper lighting domes in the rear and volatile spaces produces several intimate special spaces there. The left picture I thank to my friend Dino who took it just some days ago. But it gives very well the result we wanted to obtain. The next one. The last component of our design was the belfry. Since '68, I was working alone without my former partner and tried several solutions until I finally chose a sort of concrete stela as my own homage to our ancient Maya architecture. It was finished with stoneware stripes around 57, and that finished the solution. Next. And that it is the final situation of the church in this middle-class neighborhood. Next. The lessons learned at my two first churches at El Rosedal and Xotepingo neighborhoods gave me more security in other two cases, like this one in the neighborhood of El Reloj between 1965 and '85. The main roof consists of two asymmetrical hypars plus one more symmetrical. This church started with a small chapel covered by two conoids. You can see them in the picture to the right and behind the formwork of the roof, no? And this is our model. This was our model, and the final result. All these churches have been are in very good condition, structural condition, even after very strong earthquake we had, not only in '85, but only recently the last year, and they didn't suffer anything. Next. And this other example between '67 and '68. The St. Mary of the Apostle Church of 4 hypars and 1 conoid, which was the design was very easily obtained because from sketches like this one at the left, we only have to understand how would we trace the hypars and transform it into a roof. No? Thank you. I think it is all. Oh, yeah, this is the final result of this church. Well, I thank you very much for your attention and
please, can I ask for this afternoon's speakers to come to the table to the last round of questions and commentaries?
It's not a question, it's an affirmation. Heinz Isler models reminds me Antonio Gaudí models. Antonio Gaudí made a lot of models with catenary systems. Antonio Gaudí known all the geometry and all the forces and all the structural work empirically. There were not equations in Antonio Gaudí structures. I think that is very similar of Isler models. I don't know what you think about it.
Yes, I think he was obviously aware of Gaudí's work, but there are photographs of Gaudí's hanging models with cloth on them. but the cloth is not part of the form finding. The Gaudi models are only with rings, so they are not three-dimensional surfaces directly, and that's the difference between the Gaudi models and the Heinz-Isler models. I think that with Heinz-Isler they are actually the full surface structure. And obviously the final ones are made with latex rubber, which is a full surface.
I have as well a question for the Isler group, for both of you. And I'm interested, I mean, we already spoke a lot about how he found out about these three methodologies and if there are really only three methodologies or there are more. But beyond that, I would be interested when he started to elaborate on each of them, how did he proceed? Because it seemed that he had a very specific values, and I assume that he probably elaborated a kind of range, so that he had certain parameters like the rise or the span that he predefined. And I would be interested if there is a kind of spectrum that goes beyond these specific parameters that we have seen in the lecture. Do we have any documentation on that, or what would be their origin?
For the bubble shells, I'm not sure that he did have those in mind initially, but at his presentation in 1959, he listed factors for shell design on the board, and one of those was definitely efficiency. And when you're using the hanging models, you can have a large surface and get a very curved shell, or you can have a small piece of material and get a very flat shell. The very flat shell has high stresses in it, and therefore, perhaps going to have problems structurally. The larger hanging model has lower stresses, but a lot greater area of volume of material and a larger space that you have to heat and so on. So he was considering all of those aspects in his design. All of those surfaces work as a shell structure. Yeah.
Compression only.
Yeah, but one thing, of course, that I don't think I mentioned as I was going along, that in my lecture earlier, that that only works for the self-weight. Self-weight is the load on that surface. Any other loading, that is not the perfect surface anymore. So the solution is only for one load case, and all structures are subject to more than one load case.
But that's maybe an interesting point, because you mentioned efficiency before. And so first, is it efficiency about material or efficiency about low distribution of the forces? Because that wouldn't be the same, like you explained. Yeah, and the second would be then how runs this aspect of efficiency against redundancy of your last point. So there must be a kind of approximation or negotiation between these aspects.
There must be, but I'm not Heinz-Isler, so I can't tell you what his thinking was. Yeah. But he definitely, if you look in the photograph that was shown earlier of the discussion, I think it was Unam showed it. There were items listed on the board. In the report of the session, the question session, it lists, I think, 5 aspects, but actually there were 6 aspects that were shown on the board. And he definitely said that the most important was the shaping, but I think the most important was the decision about what is the best shape.
Yeah, the parameters for the shape. Yeah.
And only he knows that. Only he knows the criteria he was using to choose what he thought was the best shape, which could be aesthetics in the end. We don't know.
Aesthetics.
Could be. They obviously come in there somewhere.
Yeah, thank you for the presentations. This is connected to Luca's questions also for the Isler group. John, you mentioned the expansion forms and that they hadn't been mentioned in 59, but he nevertheless used them besides of their, let's say, obvious structural flaws, and then also soon abandoned them only a few years later. Could you elaborate a little bit on that? Like, why didn't he include that in the presentation? Why did he use these methods, and why did he use them only for a brief period?
I think he didn't include them in 1959 because he hadn't actually observed that phenomenon or used that phenomenon by the time of 59. I think it came later, so it wasn't included in the paper in 1959. A bit closer. Sorry, that's distracted me. I forgot after the jet lag. What was the rest of the question? Can you?
No, I mean, Solo Touring was, for instance, 1960, so that was roughly the same time.
Yeah.
So why do you think he did not include it? And why did he use this method besides its obvious structural flaws? And then he also abandoned it soon afterwards in the mid-60s, I guess.
He never said to me why he had chosen that for particular forms. But obviously the expansion form and the inflated forms have their flaws. The inflated form with the membrane, the pressure is perpendicular to the surface, but the loading is gravity, which is vertically downwards, so the surface is not particularly accurate. With the flow form, there are questions about how did he measure it accurately. So I think, for instance, the Wyss Garden Centre, he described it to me as a combination of spherical surfaces sort of merged in some way. And I think he saw the flow form as some sort of development of that you could produce those sort of similar surfaces. But the Reckersville structure, he often mentioned that there were one or two of his structures that he was quite concerned about. And I think that could have been one of them, because you have got sort of very slender supports and potential for buckling there. But that is based on the flow form. And maybe that's why he abandoned it, because he was concerned about the stability.
Yeah, thank you.
But the answer is, I don't know. He never mentioned it, why he'd done
that. First, I want to thank John for helping me. And I have to apologize with all of you because I didn't invite you before for sharing the IASS. It's a very important association on shells, and there is a working group. I think it is now headed by Philip Locke and Sigrid Adriansens, as much as I remember. And I think it is a place where we can make us hear. We can speak and say what we are doing now, and it's something important. And the question goes to Dr. Del Pozo. He was my professor, and when I was 18 years old, maybe I saw these churches, and I was always surprised, and I said, what a beautiful building. Who did it? Who built it? And sometimes I heard Candela, sometimes I heard Tondas, but not your name. I think it's very important that after I heard this lecture, I think it's very important that you leave a legacy, a book. I know you have written some books. The question is there a book where you have written all what you show us today, or not?
Well, there is a book with an article inside. It's a collection of 25 essays of mine that is already published. And one of them deals with the 4 churches I made. But it is only an article. Each church deserves a more wide explanation. Such I tried today only with the Xotepingo Church. Thank you very much.
It would be nice if we can have the possibility of having such a book for the future. Thank you.
For Dr. Alberto González Pozo too, I want to congratulate all the speakers, but the question is for Don Alberto. Which was the intervention of Juan Antonio Tonda in the structural solution of San Antonio de Padua? We visited in Sunday, and I think we are very impressed. If you can explain something about the facade, the facade and the chorus, because it's independent of the.
It's only a single piece, yes.
A single piece.
Yes.
And at last, about the design of the beautiful stairs who climb to the chorus, it's very interesting.
Yes. Well, first, we always used, either in the La Mora's office or in my own practice, first to develop the geometry of what we wanted to design. No? And so I made the geometry of the first slice, very, just in a sheet of paper. No? So. And I talked with Tonda, and he grasped it immediately, and he said me, yes, it is possible. Let me make some calculations, and I'll show you in a few days, because we have no time to build the church. And in 1 week, he had already a solution of one slice structurally. And we used this, we repeated this slice until we finished the first part of the nave, and then we added other things, no? But the process of building a church like this, with small amounts of money that the community gives each Saturday and Sunday in the masses, doesn't allow to finish the work in 1 year or 2. It needs several years. And so it gives you more time to think for an entire solution, and so we made several changes. Among them was the frontispiece, well, the frontal facade, what you name. The nave was already built, had its own foundation, and so we thought we must build a new piece, independent. The frontispiece just doesn't touch even the slice, the frontal slice. It's 1 or 2 centimeters nearby, no? And so we have to improve with Tonda, of course, as a structural consultant, the whole structure of the frontispiece and the church, the choir that is part of it, and the lateral staircase was, I had made already other stairs like that in a house, in a home, and just translated the solution to this church. Yes.
And
It gave, as I had enough time to think about all the details, I had a great pleasure with exploring alternatives and so on until I finally got the solution.
And the apsis is the last part that you built?
Yes, yes. The apsis is not the last. The last part was the belfry. The frontispieces, the facade, the main facade, came afterwards. So it's around the 80s, perhaps, and the rear apsis is early 70s, perhaps. Slowly, no? And also the crypt and was later on. Each was independent, each part was independent from the other. That didn't mean that they couldn't stand together, of course. We continued the work, but they could stand independent. We wanted to.
Congratulations. I think this master work.
Thank you very
Really.
much. Thank you.
So a very simple question to John. How do these validation models or measuring models actually work? The ones with the cables on, how do you bring the forces on and how do you measure actually? Yeah.
I think for putting the forces on the cables, they were just hanging weights or using jacks, small mini jacks to produce the force.
So that's the forces, and what are the cables doing? It's
the cables on the surface of the
Yes,
structure. They
yes.
were connected to the strain gauges measuring the stresses in the system.
okay. Yeah, thank you.
And maybe one question more, because you just show us how you love the models, and not only for the form finding process, also for stress measurement. And I always ask while I sit here and listen to your lecture, what Isler would do today after making the first sketches by hand. Maybe use a MakerBot printer and a supercomputer, and not.
He was totally averse to using computers completely. The only computer in his office, right until the very end, was a computer. Well, it was a word processor. Really, it wasn't a computer. So in his office, he did not use computers at all, and he was extremely against the use of computers. Amazingly, it was surprising. I know he quite friendly with Professor Eckhard Ramm from Stuttgart University, and he at one point he did give Eckhard Ramm some coordinates of one of his shells to do an analysis of the shell surface. And I actually had a meeting with Eckhard last week, and we were talking about it, and he said he analysed the shell and he sent the results back to Heinz Isler, and he never got a response. So either his opinion of that was either it proved that it worked perfectly, or it sort of made him worry about something in the surface, because he never got a response. And I think today well, who knows? He might be someone who came along and said, okay, yes, I'll be using Rhino for the surfaces and I'll 3D print them. But I suspect not, because of the type of person he was. He got his inspiration from nature, looking at surfaces in nature. Playing, he was sort of almost childlike in the way he liked to play with the surfaces. And you can't, but I suppose you could do that with a computer, but he always... No. Yeah. But
But architect don't name Heinz.
Yes,
Isler
might do that.
Might do, and you don't will.
He was always concerned that other people would try and copy his shells, and that they would make bad shells that were either aesthetically bad or structurally bad, but they would be labelled as Heinz Isler shells, and that would spoil his reputation. So he kept what he said were his secrets. Talking to him back in 2003 about the possibility of writing another book, he did actually say, well, I didn't tell Chilton much to go in his first book. There's a lot more that I could tell you. So he was only releasing what he wanted me to know back in 1999, but he was starting to be prepared to open up more, I think, because he was realizing that people were interested in his work and that he couldn't keep it to himself. But he did say that other people may follow on in a different way, and some people are starting to build Isler-style shells. There's a project in South Africa made out of earth bricks. I can't pronounce it properly. Mapungubwe, I think, visitor centre in architect Peter Rice, and that's, if you look at the form of those shells, they're very much like Isler shells, but they're made out of mud bricks and not reinforced concrete.
This is a question for Professor González Pozo. I am aware, well, I know that there was an art and architecture religious society in the 1950s. I don't know if you know anything about it, with De La Mora, Felix Candela. So who else was part of it, and how much of the discussions, the theoretical discussions between those members were actually influencing the religious architecture in Mexico at the time?
Well, all De La Mora production was part of geometrical solutions that were completely worked inside that office. But when they lacked the ability to calculate how would they behave and to build shells. They had only the, let's say, ¿cómo diríamos? La intuition that the geometry itself would go to a good solution, to a good statical solution. And that idea was comparted also by Candela. Candela started his own practice with very simple shells, bolts and conoids. And later on, he went with the high parts, especially with the umbrellas of one support for a high part of, let's say, 100 meters surface or 120 meters surface each one, no? But at a certain point, in the La Mora's office, who had already built a church since 1938, between 1938 and 1946, which was a parabolic shell. No, not shell. It was a thick, supported with arches. No, in Monterrey, and he wanted to explore new solutions, and so he and Fernando López Carmona, who just died several weeks ago, tried a new solution for I think the first problem they had with Candela was, well, the first job together with Candela was when they developed the main hall of the Mexican Stock Exchange in Mexico City around 53, 58. No? And they heard that Candela was already building such kind of shells and called him. And Candela came to the office of de la Mora, saw the solution, and he said, yes, we can build it. But it was the first type of hyper where two hypers crosses one to another. It was geometrical a problem to solve it really well, no? And Fernando López Carmona had found that solution. The plans of this effort still exist here in the archive of the faculty. And that, if you see the first structural plan of Candela, of that, the same structure, already with his calculations and ready for building, is exactly the same, only with calculations. No? And so they followed in the next situations, several churches, each one with several difficulties of the form, no? And they solved it. But I think that the main lessons of that partnership, of that de la Mora's office as acting as designers and leading not only the roof solution, but also the inside, all the functions inside, acoustics and other things. I like very much the approach of our colleague here, because I think what we made there was Baukunst, exactly. It was an approach more integral and more artistic. And Candela, of course, he was an architect too, but he looked more for the economy and the beauty of his structures, of course, and he could calculate them and to build them with his company, with all the problems that we also heard from the first presentations. I think that then and even today, there are many unequal things in our building construction. Of course, it's a problem of labor, of course, of unpaid labor, well-paid labor. But that was not only in building shells, but in all types of construction.
Yeah, mainly to Alberto again. And I think you answered it right at the end of your last answer. Since Maria is not here to comment on hers, but yeah, I wanted a little bit your opinion on that presentation. I mean, on one hand, it was a very challenging, provocative, and awakening, conversation. But at the same time, I think what makes because I was thinking a lot what, normally in Latin America, we work actually very closely with the contractors and the workers, different than in Europe and at least in my experience in the US, where the architect is completely detached mainly or normally from the process. We work hand by hand with the construction and especially with the workers. And my response to that was that in a way we participate of the process because we are also exploited, mainly.
And we face the same risks. And we face the same risks.
Exactly. So that was the comment I wanted to make and your opinion on that, because in a way, even though it was a phenomenally challenging proposition to look at it from the present to the past in different conditions, at the same time, it's a view from a situation that is it's still unreachable for us. The conditions haven't changed so much today in construction, and especially in the relationship between clients and architects, which is an exploitation.
I think you are completely right, and that all of well, of course, the worst part is the workers, the stonemasons and the carpenters and all the people who intervene. And of course, the system of shell building could be already in the 60s be more aided by mechanical solutions like cranes, for instance, instead of climbing all those formworks. No? But I remember that I myself, then I was young, I had no problem between 25 and 35 years to climb up and to take photographs from upwards to downwards to see how was the work going on, even in buildings of 40 meters high, without security net, no? That was usual, yes, of course. And that was all the situation of the construction industry in Latin America, of course, and other countries.
Can I just add a comment to that? If you look at where there are still shells being constructed, shells are being constructed in India, and that is a place where there is still a lot of very cheap labour. Another colleague from ISS, Raj Sundaram, has a practice in Bangalore, and he was telling me at the conference in Boston in July that he is about to build a 70-metre by 70-metre shell that is only 5 centimetres thick.
Okay, I want to congratulate especially Julia, because your presentation was beautiful. I like a lot your holistic approach to the Isler work with that context and the influences, and I think it's beautiful. Have you some kind of methodology to make this approach?
What do you intend? What do you intend? What do you? I mean, yes, of course. This is part of the research plan that I'm developing, because I have to submit in January the research plan that is about how I would like to approach my PhD research. So yes, this is basically the major steps that I would like to investigate. Now I'm focusing a bit more on the relation with the Swiss context in this moment, and in the selection of the projects that I would like to study further to develop this approach about the relation between the models, the design, and the construction techniques. Obviously, this depends also on the amount of materials that we have on the archive, because this is like the treasure that we have, and it's the main part of the research will be done there probably. Yeah.
And your graphics, we made some graphics about the work of Candela, seeing the how much projects made in different years, and how much projects built, not only develop, and all this part of the graphics, to understand the evolution, and the decrease in some cases, of the it is.
Yeah, these graphics I developed based on a list of the build projects of Heinz Isler that we received from Heinz Bosiger. That was the main contractor of Heinz Isler. And they are divided in industrial shells and freeform shells between Switzerland and the rest of the world. That's the reason why I divided between Switzerland and the rest of the world. Right now, I'm trying to have some statistical data from the Swiss government in order to cross this data of the production with the data that are from the Swiss government about the price of concrete, the price of labor, in order to try to understand if there is a connection. There should be a connection, of course, but in a more consistent way.
A part of Bechstein, you have to add to your beautiful map the work of Christiansen. John, you know Christiansen work in Seattle, in the northwest of the United States. It's very interesting too, no? And a lot, I think.
I reckon the UK.
Excuse me. Yeah. Well, I would add a little bit more to the presentation of our, because I think that if we compare Candela's production in a graph similar like you made with Isler's production, Candela, we know that built around 500 shell structures, around that. And compared with 1,400, it is a big difference. And I think that being an engineer and looking more for the physical approach, Isler's method was probably right, even if it had many problems of waiting for the model and all the process, no? But it was a good method, and that explains the production. That it is astonishing. 14,000 examples. It's easily said. 4,100, and so I think we should study more these methods of Isler's and try to learn also from that.
Can I just say, well, I was just going to say that the comparison of 1,400 shells by Isler, I would say the majority of those were his bubble shells, which were a standard model that gave contractor Berziger, he had the right to build them, and he could just repeat. So there's mass production.
If anyone else has a question or any comment you would like to make? Okay, so we will close for today, thanking our 4 speakers of the day, and you should tell Maria Pendas that her conference was very debated. And thank you very much for being here. So we will close for today, and we'll see you tomorrow. Thank you very much.